All right, let's get started. Thanks for attending our webinar about Morningstar solar charge controllers and inverters. This is Mark McHenry. I'm here along with Roy Butler, who will help answer any questions that you have during this webinar as time permits. So if you have a question, just go ahead and type it into the questions chat box at the bottom of your GoToWebinar pane. We'll address your questions at the end of the session. I should also mention that we've attached a copy of the slide deck that we're using today, and that's in the handout section of your GoToWebinar pane, so you can go ahead and download that right now. We're recording this broadcast, and we will email you a link to the recording before the end of day tomorrow. You will also receive your NABCEP CE certificates sometime early next week for attending. All right, so let's go ahead and take a look at the agenda for today. I'm going to start off with a brief introduction about Morningstar and an overview of solar controllers and inverters. Then I'll cover PWM versus MPPT controllers, efficiency and oversizing. We'll share some examples of Morningstar products, and we'll end with the Q&A session. Let me start by sharing a little information about Morningstar. You can see on this slide, Morningstar is a U.S. company that conducts business through authorized distributors and dealers all over the world. Since 1993, we've been a leading supplier of solar charge controllers and inverters. We're considered to be the charging experts, and we've sold over 4 million controllers and inverters for all types of industrial, mobile, and residential applications. And we have the lowest hardware failure rate in the industry. This webinar provides a general overview of Morningstar and its complete line of off-grid solar charge controllers and inverters. We welcome any questions that you might want to text into us today about our legacy products and also our new SureSign inverter line and the new Genstar MPPT high amperage DC charging system controllers that we started shipping from our warehouses in Q2 of this year. If you click on the large banner on the home page of our website, you'll be directed to a landing page that provides data sheets, videos, and other information about these two products. Also, if you navigate to our resources and webinars tabs on our website, you can access recorded webinars that cover these two new products in detail. But staying on topic, let's go ahead and take a look at the next slide, which describes Morningstar's product series. Morningstar has 3 product series. The Essential series that you see on the left, this is a line of Morningstar controllers that are based on the Professional series, but with features catering to smaller residential or recreational projects rather than industrial commercial systems that might require special certifications or data communications capabilities. In effect, Essentials is a Morningstar consumer or do-it-yourselfer line. It provides access to Morningstar quality and technology in more price-sensitive projects. It's important to note that the Essential series is not offered in the US and Canada. But next, the Professional series that you see in the middle, this contains products that are offered globally. And many of the Professional series controllers have communications and data logging capabilities, as well as special certifications that are not found in other charge controllers. And then lastly, on the right, our integrated series, which includes our new Genstar MPPT controllers. This has the most robust features to manage multiple loads, as well as a built-in ready rail that makes it very easy to add modules that enable relay, BMS, and shunt functions. The off-grid power applications that use Morningstar controllers are remote sites that are not connected to the electric grid. There's no utility company involved. All power has to be generated by a system at the remote site. And the main reason why people build off-grid systems rather than connecting to the electric grid at a remote site is predicated on cost. It costs about $50,000 per mile of wire to connect to the grid, and this cost can be even higher if there's difficult terrain involved, such as mountains, rivers, or forests. You can see here that there are different sources of off-grid power. For high power needs, systems using fuel generators are sometimes an option. One problem with this, however, is the cost of fuel and the cost to transport fuel to the site. Another problem is the CO2 emissions from fuel generators. Wind and hydro systems are sometimes considered, but not all remote areas have consistent or adequate wind and hydro sources. Thirdly, you see that fuel cells are also used in some cases. And if the power needs are not too high, such as in the applications that we're going to see on the next slide, then solar is an excellent source of power. Solar power is used to run electrical loads during the day and to charge a battery so that at nighttime, when there is no sunlight, the battery can be used to run the loads. And in places that experience a limited amount of sunshine, hybrid systems that combine solar, wind, hydro, and/or fuel may be used. All right, on this slide, you see some examples of off-grid applications where our charge controllers are used. In addition to residential and mobile home systems, Morningstar products are used in industrial applications at remote oil and gas sites and also telecommunication sites. They're also deployed in remote security surveillance, traffic, lighting, and railroad signaling applications. These applications differ from the grid-tied systems that many people are used to seeing in their neighborhoods, whereby the homeowners are selling back power to the utility company. And likewise, the solar panels and systems that people see on top of some football stadiums, those are also generally connected to the grid. So those aren't the same as the off-grid applications where Morningstar products are used. So let's talk a little bit about the solar charge controller. A charge controller maintains the battery at its highest state of charge while protecting the battery from overcharge by the PV array. Some controllers include load control for low voltage disconnect to protect the batteries from over discharge. In addition, they can offer lighting control to turn lights on during the evening and off during the day. Charge controllers can also provide system status indicators with meters and LEDs to display battery voltages, current, system operating temperatures, and alerts. Additionally, some controllers include data logging as well as communications and monitoring capabilities via Modbus or SNMP protocols. The charge controller generally represents about 10% of your total system costs, and a good controller will extend battery life, so that's very important. Batteries can be about 40% of your first-time costs and about 80% of your lifetime costs, and a poor controller can cause battery failure and complete failure with your entire solar system. Reliable charging to maintain battery health and extend battery life is affected by how well and also how fast the controller software controls the electronic component hardware. Battery and PV voltage and current can change in split seconds, and the power electronics have to be able to respond fast enough. Most people don't see these dramatic swings going on within their controllers and inverters, but if they did have scopes and sophisticated monitors that could show what's actually happening, they could tell which controllers are going to have the best effect on battery life. So the bottom line here is you can have the best batteries and best modules in the world, but they're only as reliable as your controller. And to give you a better idea how a charge controller fits into an off-grid system, let's go ahead and take a look at a wire diagram that illustrates connections and power flow. All right, this diagram displays the Morningstar controller and other components of an off-grid system and how they're connected to power a direct current or DC load, such as the light in this example. And what's happening here is sunlight is contacting the solar modules, which convert solar into DC electrical power that it delivers to a charge controller. The charge controller regulates the amperage and voltage that is delivered to the loads. And then any excess power is delivered to the battery, so the batteries maintain their state of charge without getting overcharged. Then during the evening, when there's no sunlight, battery is used to power the load. And you might notice that the battery is grounded at the negative battery terminal. You can see that right here, and this is because all of our controllers have a common negative ground. Therefore, it's possible to establish a common negative ground for the entire system. That includes the solar array, the battery, the controller, and the load. This meets NEC code requirements for grounding. Morningstar controllers can also be used in positive ground applications as long as proper guidance is followed. And you can go ahead and contact us for more information about that if it's needed. Now, to better understand the power flow on this slide, we ghosted out the charge controller, and this example shows power flow during the daytime on a bright sunny day when the PV module is delivering power to the loads and also the battery. And these are included in your slide, so I just wanted to have you have this for your reference if you ever need to go back and kind of look at this. We have some more illustrations. Here's an example of power flow during the daytime when load power draw exceeds the power supplied by the PV modules. So in this case, the battery is also delivering power to the load, so you can see the power flow here. This could happen during cloudy periods of the day or during the early morning or late evening. And then in this example, the load is turned off and the PV module is delivering power to the battery only and not to the load. And then lastly, this diagram shows power flow during evening when there is no power being supplied by the sun and the solar module and the battery alone is running the load. I should say the battery alone is running the load. As a reminder, all these power flow diagrams that we just looked at relate to direct power or DC power loads. But on the next slide, we're going to take a quick look at a diagram that relates to loads that run off of alternating current or AC power. So let me advance the slide. And this diagram with an AC load looks very similar to the earlier example that we saw with the DC load, except that in this example, we've added an inverter to the system. And the purpose of the inverter is to convert the DC power from the battery to AC power that can be used to run an AC load like the TV that you see on the slide. And you might have noticed that we're connecting the inverter directly from the battery, as you can see here, not the controller's load terminals like we did in the DC load example. And that's because the inverter can have a high energy surge upon startup, and this high current surge might be higher than the rated capacity of the charge controller, whereas the batteries will be able to meet the high energy surge requirement. When installing a controller, it's recommended that you connect and disconnect in the following order. You want to connect the battery to the controller first, then you want to connect the PV array to the controller, and lastly, you connect the load to the controller. And when disconnecting, you reverse that order. The battery provides power to the controller, so always make sure that the controller and loads are disconnected before connecting or disconnecting the battery from the controller. And this applies to all Morningstar controllers. All right, this graphic illustrates the Morningstar controller's multi-stage battery charging process. The first stage is bulk charging, delivering maximum allowable current into the battery to bring it up to a state of charge of about 80 to 90%. During bulk charging, the battery's voltage increases to about 14.5 volts for a nominal 12-volt battery. Then when the battery reaches the absorption voltage set point, constant voltage regulation is applied, but the current is reduced as the batteries approach a full state of charge, and this prevents heating and excessive battery gassing. When absorption charging is complete, the battery has about 98% state of charge. Then the charging current is reduced further, so the battery voltage drops down to the float voltage. For flooded open vent batteries, an equalization charge is applied once every 2 to 4 weeks to maintain consistent specific gravities among individual battery cells. The more deeply a battery is discharged on a daily basis, the more often equalization charging is required. Equalization is most often associated with flooded batteries, and in the past, manufacturers of sealed, gel, or valve-regulated batteries often advise against equalization charging since these non-flooded batteries are more prone to damage from equalization. Some of these manufacturers now, however, recommend a small amount of equalization charging under certain circumstances, but make sure to consult your battery manufacturer for equalization charging recommendations concerning these types of batteries. It's also important to note that this slide pertains to lead acid batteries. Other battery chemistries may have different charging requirements. Although lead acid batteries are the most common type of battery used in off-grid solar systems, lithium and other battery chemistries have gained a lot of traction. we launched an energy storage partner program several years ago, and this program involves work with many lithium iron phosphate battery manufacturers to maintain the highest state of charge for their batteries and to help maximize battery life. And here at the bottom of the slide, you see there is a link to our webpage that will let you download integration guides for Trojan, Discover, NEC, Power Plus, Relion, Simplify, Pylon Tech, and many other lithium iron phosphate batteries. And the integration guides provide custom settings information to help you charge your batteries safely and to prolong battery life. Another way of accessing the implementation guides for specific lithium batteries by clicking on the Resources tab of our website and then clicking on the Energy Storage Partner menu item. Once you do that, you just click on a battery brand to access a guide, like I'm going to share with you on the next slide. So let me forward to that. Here you see an example of an integration guide. We provide an overview of the lithium battery brand, and then we provide optimal controller settings that you should input concerning absorption voltage, also battery high voltage disconnect and reconnect set points. We also provide battery current limits and other optional recommended settings in addition to links to configuration files. So there's lots of good information on the Energy Storage Partner Program webpage. And if you're using lithium batteries or thinking about using lithium batteries, you'll definitely want to visit this page. All right, here's some things to consider when deciding whether or not to use lithium or lead acid batteries. So for lithium batteries, if a battery management system or BMS isn't installed with the battery, you'll probably need one. A BMS is an electronic system for balancing and protecting battery cells. Lithium batteries will generally be advantageous in terms of weight, cycle life, depth of discharge, round-trip efficiency, partial state of charge effects. They're also advantageous in terms of energy density and maximum allowable charge and discharge rates. But lead acid is advantageous in terms of temperature tolerances, especially low temperatures. Also, lead acid should be easier to recycle, and it has a lower upfront cost. And then lastly, since people have been using lead acid for a long time in off-grid applications, these batteries might be more familiar and easier to use. All right, the two major types of solar charge controllers that Morningstar offers are pulse width modulation, or PWM controllers. And then secondly, maximum power point tracking, or MPPT controllers. Both of these types of controllers are of equal Morningstar quality. PWM controllers operate at battery voltage. They're less expensive and they work well in locations where there's consistent, abundant sunshine, and economics favor installing more panels instead of more costly balance of system components. MPPT controllers, on the other hand, they operate at maximum power voltage, PMP, which is higher than battery voltage. They're ideal in intermittent sun and cloudy conditions, and also in cold weather where they boost module output more than in warm weather. MPPT controllers can be used with oversized PV arrays, and they have less module restrictions than PWM controllers, so they can also be used with 60-cell modules that are often unsuitable for PWM controllers. And here's how to access information to help you choose the right PWM or MPPT charge controller that meets the specifications for your project. So let me advance the slide. If you go to our website and you click under products in the top menu of morningstarcorp.com and then click on solar charge controllers. If you're looking for basic information concerning PWM controllers, just choose PWM under technology, and then you'll see all of our PWM controllers. You can filter further by battery voltage and charge current ratings. And for more detailed information about dimensions, certifications, protections, maximum solar inputs, operation temperatures, model numbers, and more, you would just click on any of the displayed products and check out the web page content, as well as the data sheets, operation manuals, and videos. If, on the other hand, you're considering MPPT controllers, you would just click on the MPPT underneath technology. Then you can filter further by battery voltage and charge current ratings. On the right, you will see all of the available charge controllers that match your filter choice. And if you're in the US or Canada, you would want to click on any of the integrated or professional series controllers. In order to better understand what makes Morningstar controllers unique, let's go ahead and take a look at our ProStar MPPT controller as an example. The ProStar MPPT is a mid-range MPPT controller that comes in 25 and 40 amp charge ratings for 12 and 24 volt battery systems. The high-frequency design allows the controller to react to rapidly changing conditions. This provides higher efficiency over a wide variety of power ranges. Morningstar's TrackStar technology provides industry-leading sweeping speed of the entire IV curve and leads to a higher energy harvest compared to our competitors. Regarding our high-temperature architecture, Morningstar uses a higher grade of copper poor in our printed circuit boards, higher temperature rated terminals, and 105 degrees Celsius rated capacitors for reliable off-grid operation, even in extreme temperatures. So this all adds up to very long life and high reliability of the electronic components. The ProStar's case is very durable, much more durable and protective than thermoplastics that are used in other controller brands. And if you're using lithium batteries, sometimes temperatures delve into the ranges that are outside the charging window for the battery. Morningstar's battery charging algorithm can be set to account for low temperatures and reduce charging current during those periods in order to maintain long battery life. Many controller brands have a 2-year warranty, but the ProStar MPPT and our other professional series controllers have a 5-year warranty. And the ProStar MPPT, like all Morningstar controllers, are passively cooled without fans, which can be a point of failure. All right, now let's take the cover off the ProStar MPPT and take a look inside. The ProStar MPPT's meter provides a clear, crisp backlight for high visibility, even in direct sunlight. LED lights will display or flash different colors to alert you if you have made any installation errors or if your controller is experiencing a short circuit or high temperatures or high voltage inputs. Our specific choice of coil-craft inductors are made for compact design, high-speed operation, and surface mount manufacturing to maximize design longevity. Morningstar uses ARM processors for their high-speed controllability and extensive I/O and memory features. A 3-phase high-frequency design in our MPPT buck converter allows us to cancel much of the DC ripple, which is both hard on power electronics as well as the battery. We use fast-acting transient voltage suppressors in all of our designs, and this product is no exception. These devices don't degrade and are designed to last as long as the product life to prevent the number one cause of failure, which is induced surge damage from nearby lightning strikes. The wire terminals are high torque and corrosion resistant and large to help facilitate easy and reliable wire connections. The data port on this controller provides or supports Modbus protocol, and the ProStar MPPT has up to 256 days of data logging of battery voltages, absorption charging times, and power inputs and outputs from the controller. We use the direct FET package for much of our switching technology because of the benefits of cooling, compact design, and reliable surface mount technology. By applying them on the backside of our board in direct contact with the heatsink thermal pad, they stay extremely cool. We use an extruded heatsink design, which contains more pure aluminum than cast designs and ensures very high conductivity. Lastly, the ProStar MPPT is now rated for use in hazardous locations where flammable chemicals may be present, such as acetylene, hydrogen, gasoline, acetone, benzene, propane, and methane. Our SunSaver PWM and SunKeeper controllers have been rated for use in Class 1 Division 2 Group A through D locations for many years, but now our ProStar MPPT, also our ProStar Gen 3 PWM, and our SunSaver MPPT are all rated for such use, and they carry the North American, European, and international HAZLOC markings. This is a major development for those involved with off-grid oil and gas sites or applications, also mining, chemical processing, and environmental cleanup operations that require charge controllers with HAZLOC ratings and higher output power requirements. And we've included a cutout here, a cutout view of our newest controller. This is our Genstar MPPT controller. We've recorded webinars on our website about this new product, but I just wanted to attach this slide to your handouts so you can get acquainted with the Genstar MPPT, which comes in 60, 80, and 100 amp models with a maximum VOC rating of 200 volts. And this can charge 12, 24, and 48 volt batteries. Also, I wanted to point out that we've created ready block accessories associated with this unit. Those are the ready relay, the ready shunt, and the ready BMS blocks that enable generator starts and stops, state of charge calculations, and lithium battery management. Here you can see one of the ready blocks. This is actually the ready relay that goes on the ready rail here that you can see on this controller cutout. All right, we took a look at Morningstar's ProStar MPPT and Genstar MPPT, but here are some common characteristics of all of our charge controllers. So all Morningstar controllers in our professional series and integrated series have a 5-year warranty. Essential series controllers have a 2-year warranty. We're supported by select wholesale distributors. Many of them have been with us since our inception. Also, our controllers are manufactured in a certified ISO 9001 facility and subjected to strict quality control guidelines. Morningstar controllers are passively cooled and they have no fans or moving parts that can be a point of failure. This also keeps dust away from the circuit boards. Our controllers perform well through a wide range of temperatures, from well below freezing to well above room temperatures. So it's very common to see Morningstar controllers in some of the very cold Arctic regions of the world, as well as some of the hottest jungles and deserts. And then lastly, you see here, all of our controllers have lightning and transient surge protection. Morningstar controllers are easy to integrate with all types of solar modules, batteries, inverters, and other balance of system components. With factory presets or saved custom settings, our customers often say you can set it and forget it. Environmental protections associated with Morningstar controllers include epoxy encapsulation and conformal coating. And to illustrate a point about epoxy encapsulation, I'm going to use an example of our SunSaver controller here. In the picture that you see now, the cover is on the controller, but now I'm going to show you a picture of the cover off so you can see the epoxy underneath it. And this epoxy protection is like hard plastic that completely covers and isolates all the electrical components and the PC board. This protects against humidity and airborne particles. It's a best practice for electrical device manufacturing. Many controller brands don't have this protection, but Morningstar controllers certainly do. Conformal coating is applied by a spray that goes over the circuit boards to protect against dampness and corrosion. The nozzle that you see in this slide, this sprays a very fine mist of epoxy or silicone coating, and it travels up and down and across the entire circuit board to apply a coating that will provide additional protection against moisture, dust, and other contaminants. We use surface mount components that are precisely assembled by machine, not hand assembly, so this makes for a very reliable, high quality product. All right, next we're going to take a look at how the efficiency of a Morningstar controller varies at different power output levels. So let me advance to that slide. Efficiency is a ratio of controller output power to input power from the PV array. Or another way of looking at it, how much power is lost by the controller in the form of heat because of inefficiencies. You see how on this MPPT controller graph of efficiency versus output power, the Morningstar controller that's represented by this orange line, you can see how it provides significantly higher efficiency at both the low, medium, and high output power levels, whereas the other controller's efficiency represented by the blue line, you can see how it drops off rather dramatically at output power levels away from its peak efficiency, which is right about here. You can see how the Morningstar controller reaches near peak efficiency very quickly and then remains at high efficiency throughout virtually all power levels on the graph. Other MPPT brands have been shown to have more than 2 times the energy losses at higher output power levels. So when a manufacturer quotes you a conversion efficiency for a controller, you need to know the output power at which that efficiency was calculated, and also how much that efficiency will vary at higher output power levels. In a grid-tied system, a 0.25% difference in efficiency is considered to be a big deal. We're talking about 1% to even 3% difference here, which is a huge difference. So really you have to appreciate what might otherwise be perceived as a small difference. 99 and 98 might sound pretty similar, but when you're talking about efficiencies, it's a big difference. Another way to look at this is twice as much energy is being lost in the form of heat in the 98% scenario. So let me close on the topic of efficiency and move on to another topic that we got a lot of questions about, and that is questions about oversizing PV arrays with Morningstar MPPT controllers. Now it's important to note that the point I'm about to make here about array oversizing only applies to our MPPT controllers, not our PWM controllers. I'm going to use our SunSaver MPPT controller as an example, but oversizing also applies to our ProStar MPPT, our TriStar MPPT, and our Genstar MPPT controller families. So in this example, the SunSaver MPPT has a nominal maximum operating power of 200 watts, but using a 240 watt module won't damage the controller and won't cause it to exceed its rated 15 amps of output current. Now, just to be clear, in this example, I'm saying oversizing the wattage won't damage the controller as long as you don't exceed VOC limits in the operation manual and you adhere to other operating guidelines in the Morningstar manual. Now, you can read more about oversizing, array oversizing, at this link here at the bottom of the slide, and that's a white paper that's on our website. But on the next slide, I'm going to take a look at a graphical view of what's going on in this example. So let me advance to that slide. And what I'm going to do is create a graph of operating power versus time of day for the SunSaver MPPT controller that has a maximum operating power rating of 200 watts. And here we're comparing performance of a 200 watt module represented by a black curved line to that of a 240 watt module that's represented by a blue line. And this is an operation on a clear sunny day at standard test conditions and maximum power PMP. When using the 240 watt module, even though the power being delivered to the battery is limited to 200 watts, and the red area that you're starting to see now at the top of the production curve represents lost power, the larger 240 watt module is still harvesting more energy than the 200 watt module as shown in the green area that's appearing now. The larger module will provide better production with no power shaving early and late in the day as compared to a smaller module. And in this case, almost twice as much energy is gained, that's the green area, in the green area than is lost in the red area. And you get about 12.5% more energy available to charge your batteries than you would with the 200 watt module. All right, and again, this depicts a perfectly sunny day. But what happens on days when it isn't clear and sunny? So what we're going to do is take a look at this next slide, which shows a graph using real array data to depict what happens on days with intermittent sun and clouds for the 200 watt and 240 watt modules. So on these days, there's going to be little or no power shaving, and the extra power will serve the battery well with more energy harvest. On this day for the 240 watt module, there's less than 1% loss of power due to power shaving. That's the energy that you see above the red line. So almost all the excess power, that's the blue over the black that you see throughout this graph, all of that excess power can be used for charging. So systems that experience a lot of intermittent sun and shading during the day are very good candidates for oversized arrays. Now, in addition to controllers, Morningstar offers inverters and accessories, and we're going to take a quick look at them on the following slides. Start off with the new SureSine Pure Sine Wave and off-grid inverter. These, as I mentioned earlier, we recently launched them to convert DC power to AC power. They're designed for use in a wide variety of industrial, commercial, residential, and mobile applications where no utility grid is involved. Many of our customers have been asking us to build inverters that support 24 and 48 volt batteries in addition to 12 volt batteries, and we now offer these modules or models, these inverters that are rated for each of those battery types. And the power range goes all the way from 150 watts on the low side all the way up to 2500 watt versions. The new SureSines can handle a power surge up to 2 times the normal operating power rating. They're industrial grade, high efficiency, and perform well in temperatures well above room temperature. These units meet North American and international certifications, voltage and frequency specs. SureSines can use Bluetooth or manual dip switches to customize settings. These inverters have status LEDs to provide notification about system alerts and to ensure reliable operation. And lastly, all the SureSines have a passive thermal heatsink to dissipate heat without the use of fans. Fans are a parasitic load, and they draw in dust and debris, and they are another component that's subject to failure. So all of these inverters are fanless. And here you see the DC input end of the new SureSine inverter. In addition to the red and black positive and negative battery terminals, you see the communication ports that include Ethernet, USB, and MS CAN. As I mentioned before, you can customize inverter settings via manual dip switches or through a digital interface that you can access through Bluetooth. And here you see the AC output end of the new SureSines. On the left, you see an example of a SureSine with hardwired terminals, which are available for all global markets and all power levels. On the right, you see the Type B terminal for North American markets that's available on 150, 300, and 700 watt SureSine models. And we also have universal outlets for international 150, 300, and 700 watt models. Here's a cutout of the SureSine that's included in your handouts. You can check out recorded webinars about this product that we have on our website under the resources tab, and you can certainly text any questions that you might have about this product. The SureSine has wireless Android and iOS utility apps to use for setup and configurations. And these apps enable remote monitoring via your cell phone. And at the moment right now, I'm going to shift gears away from the new SureSine inverters and take a look at the first off-grid inverter that we launched that a lot of these newer SureSines were based off of. And that is the SureSine Classic. So here you see the SureSine Classic off-grid inverter that has had for many years of success since 2006. We still offer this SureSine Classic for those looking for a tried and tested rugged 300 watt 12 volt battery inverter for harsh environments and applications that don't require the communications capabilities and larger battery and power output support of the new SureSines. And these SureSine Classic inverters are ideal for rural electrification, small telecom, RV caravan, and marine installations requiring AC power. SureSine Classic has a low self-consumption of 450 milliamps when powering loads. During no load conditions, the SureSine Classic automatically powers down to standby mode, and self-consumption is reduced to 10% of operating consumption. It's available in 115 volts at 60 hertz or 220 volts at 50 hertz output versions. This unit provides 300 watts of continuous power, and it has a 600 watt surge peak power rating for 10 minutes. SureSign Classic has a 12 volt input. It's highly reliable, and it's equipped with an environmentally ruggedized chassis design. All right, now that we've covered controllers and inverters, let's take a quick look at our ReadyRail products and accessories. This displays our website access to our ReadyRail products and accessories. The Ready BMS, Ready Shunt, and Ready Relay that you see in the upper right support our new Genstar MPPT products. And our accessories include a ground fault protection device, optional meters, communication adapters, and remote temperature sensors. A lot of people ask if we have, as a matter of fact, I just saw an email come in the other day, somebody asking if we have an adapter to connect a laptop computer using a USB adapter. And the answer is yes, we certainly do. That adapter is called our USB meter bus adapter, and the SKU is UMC-1. Each of our accessory pages lists compatible Morningstar products, and each of our product pages lists compatible accessories. And I want to highlight the Ethernet meter bus converter on the next slide. It's a pretty popular accessory. All right, what you see on this slide is the Ethernet meter bus converter accessory, or EMC1 device, that converts a serial connection to an Ethernet connection. This enables compatible Morningstar products to be connected to an IP network and the internet to facilitate remote monitoring and remote system settings adjustments from almost anywhere in the world. The EMC1 is compatible with all of our MPPT controllers, as well as our TriStar PWM, ProStar Gen 3 PWM controller, and also our SunSaver Duo controllers and the SureSign inverters. The EMC1 helps facilitate Morningstar Live View and MS View connectivity. Also facilitates Modbus communications, and the most recent firmware update supports SNMP protocol for all products on this slide except the SunSaver Duo. And that might be beneficial to those of you who have network management software to monitor your networks. And what you see on this slide, you see a diagram of how connections are made with the RJ11 cord between the Morningstar product on the right and the EMC1 in the middle. And the EMC1 is connected to an Ethernet gateway, which is typically a router or switch that you see here on the left. So, for example, many of you might have legacy Morningstar products that up until now could not connect to an IP network or internet. But now, with the EMC1, if you connect the Morningstar controller or inverter to this EMC1 accessory, you can view remotely in your web browser many useful system metrics such as battery voltage, PV current, load current, and faults or errors within the system. This information will appear live in real time, so you'll see data changing without having to refresh your browser. Furthermore, you can use our free MSView software with the EMC1, so you can change your battery charging settings, low voltage disconnect settings, and lighting settings. Every product in MSView has its own setup wizard for adjusting the custom settings, and to make it easier to use MSView setup wizards, we've created a web page that lets you download custom settings configuration files. And I'll show you that on the next slide. If you go to our website and you click on the resources tab and then click custom settings in the dropdown, you'll be able to access a page that contains links to product factory preset configuration files for our applicable controllers. And you might only have to change a few settings on the configuration files to match the exact requirements of the battery brand and type that you're using. So these preset configuration files can save you a lot of time rather than having to do everything yourself to establish the values to input in MSView. We also have another useful tool on our website, and that's the Morningstar string calculator. You can access it by clicking on the resources tab on the morningstarcorp.com website. I definitely recommend that you bookmark this site, which is string-calculator.morningstarcorp.com. And this calculator lets you know how many modules you can arrange in series and parallel for a given type of module, battery system, and Morningstar charge controller in a given geographic location that has historical high and low temperatures. Then lastly, we recently launched an online Morningstar community for distributors, installers, customers, partners, and other stakeholders. We invite you to sign up to become a member, a community member, to access information, also to participate in forums and share photos of your Morningstar applications. You can access and become a community member simply by clicking on support on our MorningstarCorp.com website and then clicking on the online community block. All right, to sum things up, all charge controllers are not equal. Amperage and voltage ratings differ, and charging algorithms and advanced features and protections vary among different products and brands. Charge controllers provide core functionality to solar power systems to maintain healthy and long-lasting batteries. As I mentioned earlier, a failed controller can cause complete failure in your entire PV system. Also want to remind people to make sure to access valuable information from our website, including battery implementation guides, videos, our string sizing calculator, and also our online community. And for nearly 30 years, actually a little bit more than 30 years now, Morningstar has been focusing on designing and providing high quality, reliable products for off-grid systems to global distributors. We've had the same ownership, management, and strategy since 1993. Many of our distribution partners have been with us since our inception, and we rely on them to provide pricing information, service, and technical support for your entire solar system. All right, with that, looks like we've come to the Q&A session here. So Roy, I'm going to ask you to go ahead and take yourself off mute and test your audio to see if we can hear you.
Hi, everybody. Hope everyone's having a good day.
Yep, coming through loud and clear. All right. So we have some questions that came in.
Yeah, one of them I'd like to deal with here first, if you don't mind, Mark.
Yeah, go ahead.
Yeah, so we get asked a lot of times about charging dead batteries. Well, if it's truly dead at 0 volts, none of our controllers are going to help you. But if it's the Sunkeeper and the little SG4 basic controller, if you've got more than about 3 or 4 volts on there, it's gonna wake up and charge if you have enough sun. The everything else requires at least 8 to 10 volts to operate, so those would not be a good solution for charging a dead battery. But I just wanted to get that out there because all of our controllers are powered by the battery and not by the solar panel. So just to clear that up for folks.
All right, thanks for that question and answer. Let's see. You want me to ask these questions, Roy, or do you want to read them off and answer them? Which is the best way?
Well, if you want to go ahead and read them off, and I'll answer them.
Okay. let me do that here. I'm reading this one here. Let's see. What is this? Let's see. Let's see. I'm trying to make sure I read this right. So if a customer wants to add an EV and battery later, how would they go about doing that? Is that something we could answer in the scope of this webinar?
Well, I'm not sure that that this person understands how our equipment works. So, because our charge controllers are powered by the battery, you need to add the battery sooner rather than later. It's not going to run without the battery. You can add an EV to a large system. You know, if you have a very large home system or a small commercial system and a big enough battery bank and inverter, yeah, you can add an EV charger to that. But you might be asking something along the lines of if something like this can be added to a non-battery grid tie system, and that there are ways to do that, but we don't serve that market segment. All of our stuff is battery based.
Okay. Well, thank you for that that question and answer. And I guess this looks like a kind of a follow-up question. They're saying, so you could use Morningstar controllers for off-grid power for mountainous and rural systems in what is it, IIMCs, low and middle income countries,
It looks more like,
hospitals in remote
yeah, it looks
areas.
more like Maynard is just making a comment about some of the things that went by in the webinar.
Okay.
Maynard, if I understand your comments here, we're servicing those folks already. There are an awful lot of groups out there doing work for rural systems in low-income areas, hospitals in remote areas, missionaries and humanitarian workers, and so forth, to help Indigenous people stay indigenous and you know, not be reliant on the rest of the world. They remain independent, I guess is what I'm trying to say. So yeah, we are working with a lot of groups like that. That is one of our market segments that we do service. So it's a good point.
Okay. Well, very good. Thanks for touching on that. Let's see. A question that I don't know if anyone asked this, but a question that comes up a lot is which Morningstar controllers are best to use with lithium batteries. So
Yeah,
you want to go ahead and answer that?
that's a really good question, and there's some confusion with that. Our really basic line, the entry level charge controllers are not. That would include like the SG4, the little Sun Guard unit, PWM, the Sun Keeper. That's the one that goes right onto a junction box on the solar panel. The Sun Saver PWM series, the SS6, 10, and 20, as well as the Sun Saver Duo. Those are not compatible with lithium. Although the Sun Saver Duo can be custom programmed by PC, does not have all the settings in it that you really need for lithium. So we caution against trying that. The ones that can be used with lithiums are the ones that can be custom programmed by PC. We have our MSView software, free software, and there are various connection methods depending upon which controller you're using. But the Sunsaver MPPT, the ProStar series, the TriStar series, and the Genstar all can be custom programmed. Genstar is the easiest one because we've been listening to our customers over the years and have decided that we would streamline the programming process. There are many different ways to program the Genstar. It's quite a bit different controller. The Eco Pulse and Eco Boost, only the metered versions can be used with lithiums because they can be programmed via the display and the directional arrows. The PWM and MPPT both can be used as long as it's the metered version. So there you have it.
All righty. I see a question coming in from Walter who asks, can the new inverters be stacked so you can have a system built with 2 of the 2,500 watt inverters to provide 5,000 watts? At the present time, he's asking, can we stack these?
Yeah, unfortunately, there's no capability to stack or series these inverters, so they would have to be standalone. We get a lot of requests for that. I'm told that perhaps that may be a feature in the future, but right now they are standalone, so there's no way to stack them to increase capacity.
Okay, very good. A question here about the ready blocks that I mentioned a little bit with the Genstar and PPT that fit onto this ready rail. Can you insert the ready blocks in any order that you want?
Yes, you can. Yes, you can. There is no, you can use 3 of the same. You can use a mix of the 3 different types, and it doesn't matter which one goes in first or what order that they connect together. So yeah, very, very versatile system. I don't have it here in the shop. I don't have a lithium battery, so I wound up with a shunt block and 2 relay blocks that I'm using to run various things and also to monitor the in my home system up in the other end of the house here. I use the shunt block to monitor for a net shunt. I can see everything that goes in and out of my battery bank, and that includes inverter and everything else. So yeah, it's pretty handy. So yeah, you can mix and match and put them in any order.
All right, very good. I think we've covered everything. One question that didn't come up that we do get a lot of questions about, so I'll throw it out there, is, and I'll leave this slide up. Actually, let me advance the last slide as we kind of answer this last question. I'll go to the thank you slide. I'll just leave this up here a little longer so people have our website there if they need to go onto our website and contact us through the website. But we do get a question oftentimes about how much you can oversize PV arrays by. So you want to go ahead and tackle that question, Roy,
Sure.
is the last
And
question.
that is a good one. Yeah, we do deal with that a lot in tech support. On the PWM type controllers, SunSaver, TriStar PWM, ProStar PWM, and so forth, Eco Pulse, um, you're limited to the input voltage. Let's say on a 12-volt battery, you wouldn't want to exceed the solar input voltage by more than 30 volts, and there are input limits on the voltage on all the PWM controllers. And on the as far as for current, look at the current rating of the charge controller itself. So for example, like you've got a SunSaver 20, it's limited to 20 amps on the input. And you also have to be aware of that voltage input that I just mentioned. So you really can't oversize an array on a PWM controller. However, on an MPPT controller, you can. There really is no limit other than economics, because you are limited on the output side to the battery by the controller's current rating. So for example, if you get the TriStar MPPT 60, you could put 80 or 90 amps of controller on there, of solar on there, and you're limited by the controller's 60 amp output limit. So at some point it becomes rather silly to go higher because you're wasting your money, your solar capacity. So we generally say 30% overage is usually pretty good, although I see people go higher than that, and that's okay. Just know that the controller is going to run a little bit hotter, and so you better have some pretty good free air around it. Don't put it under a bed or in a tightly packed closet or something like that. But typically 30% is good, because you're going to lose approximately 20% of the wattage rating of the array anyway, due to the nature of solar panels. So going up to about 30% overage, you account for that, and you're going to get full output out of the charge controller.
All right, very good. All right, we had a good session here. So we're gonna, just before I close things down here, again, I just want to thank everyone for joining us here today. A reminder that your NABCEP CE credits will get sent out to you early next week. You'll also receive a recording of this webinar tomorrow via email, and there'll be a link in there to get to the recording. And when we close this out, if you can just stay on briefly, you'll see a pop-up in your browser, and there'll be a few follow-up questions for you. So if you can just answer them, we'd appreciate it. So with that, I'd like to close things out, and Roy and I would like to say thank you to everybody. Thanks.
Thanks, everybody. Have a great day.